What we know. It goes up, so they are steering the beam in.
Yes, we see that on ZDCs.
So they are finding the beams.
Yeah, so we have collision.
Do we have a duct running? No.
These are the
Collision was were here, and two only side A.
So we had more background than
Side A, yes.
We triggered, didn't we?
Ich wundere, dass das halt überall stehen. Aber
Oh, but you are getting it somewhere else. Yeah, but we'll show it here. Okay, but you already have it somewhere else?
But you have it for this one?
Wow, oh, wow, this one is fine. I'm ready for it.
Yeah, but what is done, I mean, for the ECS, take the states of the figure and the detector and the
It is only
the state of all the trigger detectors.
It's very strange because the sensor is off, you can see it next to
and the
Federico was talking to Carl.
setting some connection.
Yeah, this is really a magic moment for Alice and for the heavy ion community in general, which is present, of course, also in Atlas and in CMS. This is a moment which we've been waiting for some 20 years. Our goal is to really go a step beyond what has been done by nuclear physics so far, which is in its high energy frontier, which has been to find signals that reveal that indeed a phase transition to a core gluon plasma has taken place, to a regime in which you can really study the properties of this state. And the high energy that the LHC has gives you a whole world of new tools that you can use to actually study this state.
It's now just about 2 days after the LHC switched the first time from protons, which we've been running now for almost a year, to heavy ions. And the startup was really excellent. So everybody was hoping that the machine would behave equally well with heavy ions as it would with protons, and it behaved even better. So after a little bit more than 24 hours, we had already the first glimpse of collisions on Saturday night at 1 o'clock in the morning. The Big Bang starts here, the day we are here. What we want to study is this region, the first time that the universe did not consist only out of elementary objects, but when these elementary objects coalesced into combined objects, protons, neutrons, and later on nuclei. And having this huge energy, we should really go further away from this phase transition into this high temperature phase, when the universe had no structure, had no complex particles, only individual elementary particles.
CMS is the search for the Higgs boson gamma. Why are you interested in that?
I was checking just now. Let me see.
But you are on or not?
The high voltage is on. The voltage is
Go ahead.
Yeah. So that there aren't two steps or anything. It's no crossing angle, then
Yeah, no,
fine
but
collisions.
the point is, I think.
Zero. Basically, now they have collapsed the bomb.
The noise trigger on it.
The rates are going up?
We don't have a noise trigger. Sorry? We don't have noise trigger. Good. This is
Look, Anna. Yeah, there.
Here it is. This is the heavy ion event. This is amazing.
When we have stable beams.
So HF is a very central entry. HF is on this. You can see
First done our best in simulation.
Yesterday.
Wow, we have stars. Well, it looks nice.
The tracking is also the silicon.
Okay, 1, 2, 3. Oh, that's not bad. That is within 25 nanoseconds.
So we just started collecting data with heavy ion collisions at the LHC. We have stable beams. For the last couple of minutes we are working. CMS is working beautifully. We are collecting data with all the detectors, colorimeters, tracker, muon chambers. And so this is the beginning of new era, new physics program. Highest energy heavy ion collisions ever achieved. Highest temperatures created in the laboratory. And we expect lots of interesting new results which have to do with how the universe was behaving at the early stages, at the early first microsecond. Now,
Now I don't remember what I did with my bag.
Tornare da Lice, non sarebbe male tornare da Lice.
Ma tu devi andare al James adesso, no?
Gli stand-up fa Pedro. Prendi gli schermi.
Many people have been we've been waiting for years for this. And it's very exciting that this time has finally come, that we get to look at the data. And the last 2 or 3 days have actually been the most exciting I've had in years.
The events look beautiful. I think all of us who've been involved in this preparations for some time now are very excited to see these plots of thousands of tracks and even tens of TeV deposited in the detector, which has really never been seen before. There's more energy deposited in the detector than in any proton-proton collision for some of the most energetic events. It's really quite fascinating.